Hello there, welcome to the A-Level Maths Pure Paper 2 of June 2023. Here we're looking at question 8. Express 2 cos theta plus 8 sine theta in the form r cos theta minus alpha. R is greater than 0, alpha is in radians between 0 and 2 pi. Okay, so let's start off with r cos theta minus alpha, and then we're going to expand the brackets using the angle addition formulae. So it's going to be add sine theta sine alpha. Then we'll expand the brackets on this. R cos, I'm going to rearrange the order, cos alpha times cos theta plus r sine alpha sine theta. Okay, now this needs to be equal to 2 cos theta add 8 sine theta. So now we're going to make two simultaneous equations. One that says r cos alpha equals 2, because that is the coefficient of cos in both of these expressions here, and then r sine alpha equals 8, because that is the coefficient of sine theta. Okay, so the way we're going to solve this is treat these now as two simultaneous equations. The first thing we're going to do is do 1 squared add 2 squared. So equation 1 all squared on the left hand side add equation 2 squared on the left hand side equals 1 squared on the right hand side add 2 squared on the right hand side, which gives you r squared cos squared alpha plus r squared sine squared alpha equals 2 squared plus 8 squared. If you now factorize this, you're going to get r squared brackets cos squared plus sine squared, which will simplify to 1. So it becomes r squared equals 64 plus 4 is 68. So r is the square root of 68. Can we simplify this even more? So 4, can a 4 go into 15, 16, 17? 4 root 17. So 2 root 17, because the 4 square roots of 2. And now we're going to substitute this back into one of these equations. So now into equation 1, 2 root 17 cos alpha equals 2. So therefore cos alpha equals 1 over root 17. And then we're going to do in the calculator, make sure I'm in radians mode for this. 1 over root 17 is 1.33. So therefore, in the form r cos alpha, 2 root 17 cos theta minus 1.33. Oh, to three decimal places. Let's do that again then. To 326. 1.326. Excellent. Always worth checking that. So there we are. That's the answer to part A. The first three terms of an arithmetic sequence are cos theta plus sine theta, and cos theta plus 2 sine theta. Given that S9 represents the sum of the first 9 terms in the sequence as x varies, B, find the exact maximum value of S9, deduce the smallest possible value of x at which this maximum value of S9 occurs. Right, okay then, so we need to work out what the difference is between the terms, and then what the starting value is. So A is going to be the starting value, so A is cos x, and it looks like the addition between the terms in this sequence here is r equals, so in r it's d for difference in arithmetic sequence, r is sine x. So therefore S9 is going to be cos theta, so cos x plus, there's all of the terms added together, isn't it? So we need to use the formula n over 2 a plus n minus 1 lots of d. Okay, so in this sequence, a is the value 2, so a is the value, so n is the value 9, so 9 over 2. A is the term cos, n minus 1 will be 8, so 8 sine x. Or is it 2a? 2a plus n minus 1, yes, 2a. 2a plus n minus 1, that's a d. Close the brackets. and that is going to equal, so you want to find the maximum value of S9. So what we did in the part before is we worked out that 2 cos x plus 9 sin x was equal to 2 root 17 cos x minus 1.326. Okay, so therefore I can now answer part I, which says that the exact maximum value of S9, in this expression here, the maximum value of cos is 1, so it's going to be 9 over 2 times 2 root 17, the 2's cancel out, so it's going to be 9 root 17. Deduce the smallest possible value of x for which the maximum value of S9 occurs. So x is not a multiple, the smallest possible value of x. Does it say anything about x has to be positive? I want to say x equals 1.326 because that is when the cos graph is equal to 1, and I'll assume here that x must be positive. So there we are, that's the answer for question 8 with a total of 6 marks. Let's now move on to question 9.